So what we're going to take a look at here is simplifying square roots, and where we start with this whole process is understanding what it means to square something. So looking at what 2 squared, 5 squared, and 7 squared really mean. Remember, this doesn't mean 2 times 2, 5 times 2, or 7 times 2. It's saying this number multiplied by itself twice. So 2 squared is really 2 times 2, which would be 4. 5 squared is saying 5 times 5, which is really 25. 7 squared would be 7 times 7, which comes out to be 49. And for, if we said 2 to the third, it would be the same exact thing. In this process, it would be 2 times itself 3 times. 1, 2, 3, which would come out to be 8. But for the most part, for today, we're really only going to be looking at things that are squared. So we're not going to be looking at things that are raised to a third power. So, just a key term. If a squared equals b, then a is said to be the square root of b. So what that means is if we look at a number, say 16, the sign for square root is this. Okay, so the number that's going to be underneath that sign, that's what we're looking at. So if I say the square root of 16, what that means is what number times itself, okay, what number times itself gives me 16. So I'm saying, what times itself gives me 16? Well, if you think about this, 4 squared equals 16 because 4 times 4 equals 16. So that means 4 would be a square root of 16. But also, negative 4 times itself. Because if I do negative 4 times negative 4, the negatives would cancel out, and 4 times 4 would give me 16. So there's 2 solutions to this. Okay, for all these square root equations, for the most part, we're going to end up getting 2 solutions like we have here. So 4 and negative 4. Instead of writing 4 and negative 4, because both of these times themselves give you 16, we write it shorthand as using this little plus or minus sign. So positive 4 or negative 4. Both of those we would say would be the square roots of 16. Now, this is something that's on your guided notes, and it's going to be very important for moving forward. Just understanding these perfect squares. You guys have used these before, but this is just for reference, okay? And understand what this means. If I said the square root of 49, what that means is what number times itself gives me 49. I know it's going to be 7, but now from what I learned on the last side, I know it's also going to be negative 7. So I could say plus or minus 7. If I were to say the square root of 121, I know that can easily be reduced to a whole number, plus or minus 11. Because again, remember, 11 times 11 gives you 121. Negative 11 times negative 11 gives you 121 as well. Remember, square roots, what it means. What number times itself, here, gives you the number underneath the square root sign. So again, we would have plus or minus. Now, simplifying these, okay, just be careful about how all of these things are structured, where the minus sign is, where it's not. So, looking at square root of 64, if I were to use those perfect squares, I know that 8 squared is 64. My answer here would be 8, but we have to include the plus or minus because 8 times 8 gives you 64, but so does negative 8 times negative 8. Looking at this, number times itself gives you 0. The only thing times itself that gives you 0 would be 0. So the plus or minus is already on the outside. This section here comes out to be just 0. Moving on to number 3, we have a negative on the outside of the square root, so that's okay. We still are looking at that negative will be on the outside. Now I'm going to look at square root of 100. Again, what number times itself gives me 100 will be plus or minus 10. Now, the negative sign here really doesn't do anything to us because if we're saying we're turning that into a negative and that into a positive, it's going to be literally the same exact thing. Where we get an issue is number 4. If I take a look at number 4, square root of negative 16, no number times itself can give you a negative number, no matter what. 4 times 4 gives me positive 16. Negative 4 times negative 4 gives me positive 16 as well. Nothing gives me this. All right, I can't say 4 times negative 4 because these numbers are different. They're not the same exact thing. When we look at square roots, it's what number times itself gives you the number underneath the square root sign. So here we have no answer. You can say it however you want. You can say that there's no way that we could possibly get that. In this one, this is going to be one of the properties that we're going to look at today. When you have a fraction, you're going to look at the square root of both the top and the bottom. This is going to be a property that we'll go into later on. But for the most part, it's pretty self-explanatory. Take the square root of the top, square root of the bottom. If I'm looking here, I already have my plus or minus. B, 3 over 4. All right, we already took into account the plus and the minus for this. Now, what I want you guys to try, do this one on your own. So pause the video, go through these 4, and then see if everything worked out correctly with the answers. So here are our answers for A, B, C, and D, and if you take a look, for the most part, pretty self-explanatory from what we had just been doing, except for part D. Okay, if I look at that, no number times itself that we had been looking at cleanly is equal to 27, because I know 5 times 5 gives me 25, 6 times 6 gives me 36, so 27 falls between those two, so I know it's some number between 5 and 6, but I don't know exactly what it is yet. So you can just plug that into a calculator and you get some long decimal, but what we're going to start to do is we want to know exactly what that number is going to be, and we're going to use some properties to go ahead and simplify to get that. So here are 2 properties, and these are on your guided notes. It's called the product property and the quotient property, and we're going to use these properties to simplify radicals. So what that's saying, if I had something like the square root of 16, say that I didn't know that this is going to be plus or minus 4. Say I didn't know that. If it's something else, I can take what's underneath the square root sign, and I can break this up. Since I know 4 times 4 is equal to 16, what this property is telling me is if I have some product underneath the square root sign, like I do here, this is the same exact thing as 16, I can divide that up into 2 separate radicals. So then I could take the radical of 4 and radical 4 here, which is plus or minus 2 times plus or minus 2, which ends up coming out to be the same exact thing as we did up here. This is going to be really useful for something like the square root of 27, and you'll see why in a minute or so. But just a quick example, working backwards, if I have 2 square roots, what I can also do is I can combine them. So I could say, all right, I have 2 square roots, I'm going to combine those 2 things, 5 times 5. So looking at this, well, I know 5 times 5 is 25. So now, looking at that, I know the square root of that. I didn't know the square root of 5, I didn't know the square root of 5, but I do know the square root of 25. It's going to be plus or minus 5. Now, taking a look at this, again, we multiplied these 2 things. They were the same exact number under the square root sign, and as you look, it ended up just being that number underneath the square root sign. So square root of 5 times square root of 5 gave us the square root of 25, which simplified to just 5. That's going to be an important concept as we move forward. Now, before we really get into it, because I'm going to show you 2 methods for simplifying radicals, what prime factorization is called. So what we can do is you're going to break some number all the way down until it's completely just prime numbers. What a prime number is there's no factors. So a number, there's nothing that divides evenly into the number. So if I look at 2, all of these numbers, nothing divides into them except 1 and that number. That's a prime number then. Something like 48, well, I could break 48 up into 8 and 6. So that means that wouldn't be prime, it has factors. When we talk about prime factorization, you're taking some number and you're breaking it down until it's all prime numbers. So looking at this, you think about, all right, well, 48, I know that's 8 times 6. So I'm going to rewrite that as 8 times 6. From there, I could say, well, 8 is really 4 times 2, and 6 is really 3 times 2. On this side, 3 times 2, if I look at this, well, I know 3 times 2, there's nothing else I could break down. So this would be done. But look at this, 4 times 2. The 2 I cannot break down anymore. The 4 I could break down to 2 times 2. Now, what this means, 48 is really saying the same exact thing as 2 times 2 times 2 times 3 times 2. And if you go through and you check this, you're going to see that this is going to end up coming out to be 48. This will be an important technique for breaking down square roots. It's one method for it. So I just wanted to kind of review that. It should be something that you've seen before. So if we're going to simplify the square root of 24, there's 2 ways of doing this. The first method is going to be prime factorization. So what we're going to do is we're going to break down that 24. I'm going to look and say, all right, what times what gives me 24? Off the top of my head, I know 6 times 4. And listen, there's no set way. You could do 12 and 2, you could do 8 and 3. But I got to break this down. It can't just be 24 and 1 because that really doesn't get us anywhere. Then I'm going to look at 6. Well, what times what gives me 6? I only know 3 and 2. Now looking at that, I can't break the 3 down anymore and I can't break the 2 down anymore. So these are final numbers. This is going to be the prime numbers that I'm looking for. Same thing over here. That's going to be 2 times 2. Looking at those, all right, those are my final numbers. So what this is saying is, instead of saying the square root of 24, how I can go about writing this is square root of 3 times 2 times 2 times 2. Okay, I can break that down as so. Now, based on that property that we had talked about, I could split this up into separate square roots. I can break that down into separate square roots. Now, why does this help us? Because if I look at this, right, I don't know what the square root of 3 is. I don't know what the square root of 2 is. So, you know, like, why am I doing this? What you can end up actually using is this quick example we did. Understanding the fact that square root of 5 times the square root of 5 reduced to just plus or minus 5. So I'm looking for pairs here. If I find a pair, I've got a pair right here. Square root of 2 times square root of 2, you know, when you start to get the hang of this, you'll identify those and you'll be able to jump to the next step. But if I look at square root of 2 and square root of 2, if I multiply those two things together and I recombine them back, I get the square root of 4, which just ultimately becomes plus or minus 2. So I'm looking for a pair, and what I can really do then is combine them, and it almost like cancels out the square root. So looking at these two, that's going to really become plus or minus 2. Square root of 3, I don't know. Square root of 2, I don't know. Those are two things that I wouldn't be able to break down anymore, but I'll still multiply them together. So I'll bring the 3 and the 2 underneath the square root side to give me that square root of 6. Now, this stuff is all multiplied, so I would combine them. Square root of 2 plus or minus 2 square root of 6. That's kind of the way I would look at doing this. Now, if we take a look here, if I plug this into the calculator, I would get the same exact answer as if I plugged in square root of 24. Just a different way. Again, this is a more precise method for breaking down square roots. This is the long method. What I can also do, square root of 24, I can look across that reference sheet that is on your here it is. That is on your guided notes, perfect squares. What I can use here then is I'm going to look at 24 and say, all right, which one of these numbers is a factor of 24? As I go up, you know, what I'm looking here, which of these numbers is a factor of 24? 1 is, but that's not really going to help me. 4 is. 9 is not, 16 is not, and then 25 is bigger than 24, so I know that's not going to work. But I see this. So what I can say is I can break this down to be the square root of 4 times the square root of 6. The reason why this helps me, using that property, I could split these up. I could say square root of 4 times the square root of 6. Now, what I basically did is I broke it down into two roots. One that I can simplify, one that I can't. So I can break this part down. That's going to become plus or minus 2. And then I would have square root of 6. And that's all the stuff that I wouldn't be able to break down. And ultimately gave me the same exact thing that I got over here. Now, do I care which method you use? Not at all. You can use either. You can use prime factorization. Again, it's a longer method, but you'll always get an answer. Method 2, you got to have some number sense. You got to kind of look at the number underneath the square root side and say, all right, of all of my perfect squares, which one is a factor of this? You know, which one divides evenly into this number? And you guys are going to get plenty of practice with this. So if I take a look at these two, simplifying these expressions, again, you can use prime factorization. I'll go through that quickly. Looking at the 90, I could break down 90 as square root of 9. I could break down 90 as 9 times 10, which becomes 5 times 2, which becomes 3 times 3. Looking at all of these numbers would not be able to be broken down anymore. So I'm going to put them all underneath the square root. Square root of 3, square root of 3, square root of 5, square root of 2. I could break them down into their own square roots, like so. Now again, I'm looking for pairs. Here's a pair, square root of 3, square root of 3. So if I look at that, what that's going to come out to be would be plus or minus 3, because square root of 9, what the square root of 9 is plus or minus 3. These two, square root of 5 and square root of 2 are not a pair, so they're not going to reduce anymore, so I'm going to bring them back together underneath their square root sign, and I will multiply those two things, so 5 and 2. So I would have plus or minus 3 times the square root of 10. This is a simplified version of square root of 90. You could also use the other method, just looking at square root of 90 and think about, what square numbers are factors of this, looking up and down. 4 is not a factor this time, so this would not work. 9 is a factor, so that means what I can do is I can break it down as square root of 9 times the square root of 10. And from there, again, square root of 9 I can break down, square root of 10 I cannot, so I'm going to go ahead and break down that square root of 9. Plus or minus 3 times the square root of 10. Again, same exact answer. Doesn't matter which way you did it, but choose one. One of those methods will work. Either use prime factorization or just go ahead and use your number sense. In an example like this over here, square root of 29, if you go through the prime factorization method, this is a prime number. The only factors of it are 29 in itself. Okay? There's nothing I can do here. Right? For the most part, you're not going to get numbers like these. I just wanted to bring your attention to this, that it can happen. You can have a prime number like this, square root of 29. So looking at that, yeah, I wouldn't be able to break anything down. That's my final answer. I would not be able to simplify that. Either by looking at either method, I could either use prime factorization and say, hey, it has no factors, it's only 29 and 1. Or even if I was looking for if there were any perfect squares that are factors of this, you would say, all right, well, no, this is a prime number. I know this isn't going to work out. For the most part, that's it, and that's what we're going to continue to work on, just simplifying these, and it's a number sense practice kind of thing before we get into solving square roots solving quadratic equations using square roots. So we need this skill first.